getting a house.
Questions from the homework? Backside? Where at backside? 21, 22, 23. Okay.
Oh, yeah. Can you just go over some of the questions on the back?
Can you go over 21 and 22?
Okay, number 21's up there. It says, why does one have two real roots and one doesn't have real roots or complex roots or something like that, right? Does that make sense? Well, this top one has real roots because if I set it equal to 0 and then I solve it, I get an answer of plus or minus 2. So it crosses, if you were to graph this parabola, it would cross at 2, 0 and negative 2, 0. Wherever it crosses the x-axis becomes a I had to update my Chromebooks, I'm sorry. So this is anytime it crosses the x-axis, that means it's a real root. But this one, the bottom one, if I set this equal to 0 and try and solve it, I wind up with, and then I take the square root of both sides. And so actually the mathematical answer for this is plus or minus 2. And then I introduce I. I stands for it's an imaginary number. Imaginary number is one of the number systems, part of the complex number system. So this means it doesn't cross the x-axis at any particular point unless you created your x-axis to be imaginary numbers and your y-axis to be real numbers. But right now we're dealing with real to real. So that's 21. 22 says, will a quadratic ever have more than one y-intercept? Well, all quadratics, whether they're upside down or not, will only cross the y-axis one time. Okay, though the sideways parabolas do exist, we're not going to work with them. Sideways parabolas are not functions, so we don't work with them as far as this class goes. And then 23 said some quadratics have one x-intercept, one have two, and some have none. So I'm just going to draw 6 graphs up here. I know my smart notebook is out of date. So this one crosses twice. This one crosses twice. Can everyone see that it crosses the x-axis twice? Okay, if my vertex rests right on the line, I get one solution. So you have one solution there or there. And then you could have this or this where it does not cross the x-axis. And that just tells you that they have complex solutions. So that's 21, 22, 23 in a nutshell. Any other questions from the 12? Sure. Can I look off your page real quick? Y squared minus 4. We want to find the vertex. We want to find the x-intercepts and the y-intercept. Okay. Okay. This particular problem, we want to find the vertex. Well, the nice thing is when I graph this, if I had solved this, I already solved it a board ago. These are the two places where it will cross the x-axis. So what do you think has to happen halfway in between those 2 points in the x direction? So if it crosses the x-axis in 2 spots, what do you definitely know it's going to do with the vertex? Does the vertex happen on the left side of one of them and the right side of the other? Does the vertex happen right in between where it crosses? Does it not even, the vertex not even exist on this problem? What do you think? In the middle. It's in the middle. So what's right in the exact center of negative 2 and positive 2? 0. So my vertex is at 0, comma. That's an x value, right? 0, comma, negative 4. What did I not make sense about?
But like how would it be at 0? That's just a line.
Well, I'm not done with the point yet. Because I have it as an ordered pair, so 0, comma something. So halfway, guaranteed halfway in between these 2 points, which is 0, somewhere on that line is going to be the vertex. If I take that x value, what that vertex is, and I plug it into x up there, I get 0 squared, which is 0. 0 minus 4 is negative 4. So that's our vertex. Our x-intercepts, we already have them. That's that one and that one. How did I get them? I would have set this equal to 0. Plus or minus 2. And then the y-intercept, in this case, the y-intercept is going to be the same thing as our vertex. Okay? So if your vertex lies on the y-axis, then your vertex and the y-intercept are the same thing. Other questions from the back page? 17? All right, 17. So we have f of x is equal to negative x minus 2 quantity squared. We want the vertex, the x-intercepts, and the y-intercept. Okay. So let's see. Can I find the vertex of this? Let's see what happens if I just set this equal to 0. So I would multiply both sides by -1. Still with me? Take the square root. Still with me? And then that. So this actually has a vertex at 2, 0. That's actually the only places it will cross the x-intercept. So this is one where the vertex comes down and kisses the x-intercept. And then the y-intercept, you can get the y-intercept a couple of ways. We can go, I know the y-intercept's at something, 0. Wait, I went backwards on it. Y-intercept is at 0, something. I know I am. All right, so if I wanted to find the y-intercept, I have 0, something. 0, something. Is that an x or a y value? I know. Is that an x or a y value? That's 0. This right here. That's an x value. So I'm going to take that x value, plug it in here. So I get 0 minus 2, which is? -2. -2 quantity squared is? 4. And then I have the negative outside, so I get -4. So 0, -4.
Can't you just do like -2 squared?
Yeah, but you have to remember you have the negative outside first. Fiona, you had one. Which one? 20? You got it. F of x is equal to 2x plus 1 quantity squared. All right, so let's figure out the vertex. Actually, let's think about the x-intercept and the y-intercept. Maybe we could do those a little bit better. So if I find the x-intercept, that means I'm going to plug 0 in for my y value, which is your f of x. So that would give you 0 is equal to 2x plus 1 quantity squared. Is that okay so far? I'll divide both sides by the 2, so I still wind up with this. Make sense? Yeah. Take the square root of both sides. Well, square root of 0 is just 0. So I find that x equals -1. So that is my x-intercept. There's only one of them. That's also going to be my vertex. So my vertex and my x-intercept are the same thing. In order to find the y-intercept, I'm going to plug 0 in for x. So plug it in there. I get 1 squared, which is 1 times 2. So 0, 2, that's where it crosses the y-intercept. So a lot of times when you're working parabolas, is just recognizing where do you plug 0 in, and what does 0 plugged in result in for you? Okay? We good? Names on those, pass them forward. If you're handing in anything else of old, pass that forward as well, please. Coming back out to you is kind of multiple assignments, so grab yours, pass on the rest. Any more coming down the row? Good. Got them all? Got them all? long morning for me. All right. Okay, so I'll get those in. So a few things. Students asked, "Hey, are the grades already in the grade book?" Yes, you did fine. I think as a whole, I think the classes did well as a whole. I think the worst score, I think it was out of 72 or 73. 73? So it was out of 73. Between my two classes, I did have two people who got a 40 out of 73. So I would, if that is you, I would strongly encourage you to think about switching up what you had been doing in here. If you're getting left behind, or maybe you were just really busy during that time and you have more time to focus on this. I don't know. But I'd say the average score was probably a 59 out of 73, which is not that bad of a score. Yeah, you want to do it tomorrow? Yeah, I'll be in my office right next door during 7. Yeah. During 5th, I'll be in here during 5th. Yeah, so come on in here tomorrow. Anyone else need to make it up? I forget.
I do.
You do, and we talked, and we're doing Thursday?
Yep.
Are we doing it during this class Thursday or an off period? I don't have a class 4th, so just come next door. Love it. All right. Hey, we made a plan. That is awesome. Okay. All right. So it's kind of a thicker amount of notes. It's thicker because I didn't want to have like 4 slides per page because all of a sudden you guys are squinting too much, and then I get emails from your parents that you had to get glasses because I don't print things big enough. So just kind of looking out for y'all. Oh, perfect. Thank you. All right. So parabolas, you're going to see them. They're called quadratics. Quadratics are things that are raised to the 2nd power. Quadratics are things that you don't have a square root over the x. You don't have an x in the denominator. You just have a flat out x squared. And there's a few different forms. There's vertex, standard, and intercept form. They all have their little specialties. They are something that you should be able to go back and forth between them. Once you find the vertex of a parabola, parabolas are very easy to graph as long as you understand how the pattern graphing works. The great thing about pattern graphing is it's always going to be the same. Okay? You're going to use the same ratio depending upon what your first value is. Okay? Standard form. Standard form doesn't have any fractions in it. And standard form is good for if you, I don't know, it's the neater way of doing it. I think standard form was really created back in the day because back in the olden days when we were printing books and stuff like that, we couldn't do fractions on typewriters. So I think that's really why standard form came into existence. And then intercept form tells you just where it crosses the x-axis, and it's usually the factored form. Vertex form gets to the vertex for you pretty easily, so on and so forth. But we'll learn more about these in a little bit. So how do you know it's a quadratic? Somewhere in the problem you have this. That's your highest exponent. You can have stuff in front of it. You can have stuff after it. You can't be multiplying anything other than a number times x squared. And again, you're not going to have any variables that are in a denominator. You're not going to have any square root signs in the denominator. You're not going to have any higher exponents. So just one that you might look at could be like, that is a quadratic function. How do I know it? It's raised to the 2nd power. Okay? So that's just an example. This is actually vertex form. In vertex form and slope-intercept form, or vertex form is really going to be your friend when you're graphing parabolas a lot. Okay? Standard form is ax squared plus bx plus c, and that doesn't go into your calculator really well. Factored form will indeed graph as well on your graphing calculator, which is also great to know, but we'll get to more of that in a little bit. Okay, so when we graph this, if I were to go -2, -1, 0, 1, and 2, and I were to plug in values, I'd get that. Okay? So how did I decide -2, -1, 0, 1, and 2? Well, I had to start somewhere. And I didn't want to plug in any fractions. And I thought 2 to the left and 2 to the right of the origin might be a good starting point. How did I get 4, 1, 0, 1, and 4? I plugged those values into x. So I get -2 squared, which is 4, -1 squared, which is 1, 0 squared, which is 0, 1 squared, which is 1, and 2 squared, which is 4. And so if I plot this, this is basically what it looks like. And the big aha moment, this would actually continue. So I'd go right one up, 1, 2, 3, 4, 5, and left one up, 1, 2, 3, 4, 5. This is the parent function of a parabola. Let's connect the dots. This is what it looks like. Okay? It is symmetric about the y-axis, so this, bless you, the parent function is an even function because it's symmetric about the y-axis. Not all parabolas are symmetric, but if the vertex happens to fall on the y-axis, it would be an even function. If it shifted right or left, it's not an even function any longer. Okay, the one thing that you know, what is this point right here called? The lowest point. It's a vertex. The vertex shows you what, in this case, because it opens upward, does everyone agree it opens up? This vertex, the y component of the vertex is a minimum value. So what's my minimum value of this parabola? 0. Okay? If the parabola opened upside down, your vertex would hand you the maximum value of that parabola. Now something that's kind of cool is, watch this, ready? Right one, up one. Still with me?
Yep.
Right one, up 3. Right one, up 5. Left one, up 1. Left one, up 3. Left one, up 5. So 1, 3, 5 is a huge way of pattern graphing. It's not always going to be handed to you the perfect way, but the way that we'll show you, it'll be a lot easier to identify. Okay? So what happens when this takes place? Well, this shifts down. Okay? And again, if I were to take my values and plug just these preliminary values in, this is going to be, I'm going to get 4 minus, so that's going to be -1. Let's see, 1 squared, -1 squared is 1, that's -4, -5, -4, -1. Notice it's symmetric. This points to what our vertex is. So the nice thing is you have symmetry about your vertex. We're going to start talking about something called the Axis of Symmetry. It's just a fancy term for saying, hey, what's the x component of my vertex? What is this second one going to do? Yeah, it's going to go up 7. Okay, so again, if I use my values, and I'm sorry that my smart board is out of cahoots. It's like, hey, if you're going to use it, we're going to advertise, and then you can use it for free. All right, so I get 4. That's going to be 3. I'm going to get, that's 4. That's going to be 11. That's going to be 8. That's going to be 7. That's going to be 8. That's going to be 11. Excuse me. So again, I'm just plugging those x values in, squaring it, and then adding it to what my constant is. So if you add or subtract something outside, it's not grouped, it moves it up or down. Okay? That's what takes place. We good?
Yep.
So the pattern graphing, I want you to think of this. It really is just your odd numbers. And what it really is that whatever my a value is, and I haven't identified the a value, but if the a value is something other than 1, you multiply the a value times each of those. Okay? Notice they're odd numbers. Okay? What's the difference between the perfect squares? Difference between all perfect squares are the odd numbers. I don't know if you ever thought about that. So 0 and 1, they're perfect squares. What's the distance between 0 and 1? 1. 1 and 4, that's a perfect square. What's the distance between that? 3. 4 and 9, the distance between that is 5. 9 and 16, is 7. And keeps going and going. So the difference between two perfect squares, the adjacent perfect squares, the ones right after each other, are odd numbers always. All right. So what happens to the 1, 3, 5 pattern here? Well, this one's going to grow at 2, 6, 10. What did I just do with the 1, 3, 5? By what? The 2. What do you think is going to happen on this one? Yeah, so half, 3 over 2, 5 over 2. That's what our pattern graphing is going to do. And this isn't the only thing I'm showing you on pattern graphing. I'm showing you pattern graphing because it's a beautiful tool. And I hate to say, but when I was in Calc 3 as a sophomore in college that I finally recognized pattern graphing was there. I never knew this in high school. So you guys have, look at that. I get to teach you guys in that. It was late in life. What are you guys going to do because you're getting it early? You're going to make the world a better place for me. It's all about me. All right. Describe the parabola. It opens up or down. Find the vertex. Sketch the axis of symmetry. The axis of symmetry, this is a term that is always x equals the x part of vertex. Okay? So if you had a vertex of negative 6, 10, you had a vertex of negative 6, 10, your axis of symmetry is x equals negative 6. Okay? And the axis of symmetry acts as it's an imaginary line that you draw. It is the mirror, allows your parabola to be symmetric over that line, meaning if I folded it over that line, whatever's on the right side would map onto the left side and so on and so forth. And then the pattern graphing is huge, and then this is what we just said right here. Whatever the A value is, you're going to multiply times 1, 3, 5. Now some of you are going, what is this A value and where does it come from? The A value is whatever is attached to the x squared term or right outside the parentheses from the x squared term. Okay? Can I build upon this more? Okay. So vertex form. This gives me a vertex at h comma k. Remember, if it's grouped inside, it shifts opposite. That's why it's a positive. If it's outside, the sign stays the same. So h comma k would give me the vertex. ax squared plus bx plus c. You know, what's great about this is your quadratic formula works with this. This is what you factor to figure out where it crosses the x-axis, so on and so forth. And then this does point to, right away, 0, comma c, and that's our y-intercept. Okay? So that's really what our standard form does. It gets us to our y-intercept. The nice thing about finding the y-intercept is you know that there's some other line that's symmetric about it over the axis of symmetry. When it's in standard form, we can start finding the vertex, and we're going to touch upon that a little bit. And then this last one is intercept form. So this is where it crosses x-axis. And what has to happen in between, if it crosses the x-axis twice, what has to happen directly in between those 2 points for it to cross the x-axis? What value falls halfway in between?
0.
Not always 0.
The common value.
So critical value. The critical value is going to be the x component of your vertex. If you find the critical value, the x component of your vertex, then you can plug that x value back into your equation. You'll find the y component. So there's some tools that we can use with this. Okay. So this A value determines if it opens up or down. We already talked about h comma k. We also talked about the axis of symmetry. So the axis of symmetry definitely leads to the x component of the vertex. Why did we have the x component of the vertex be referred to as h and the y component referred to as k? I don't know. Someone in math world said, hey, this is a good idea. We're going to have the x component be called h now. Okay. I could follow that. Who the hell follows that? Can I move on?
Yep.
And all of these showed up on your paper, I believe. Okay, so they want us to describe the transformation. So write 3. Is that okay? And then I'm going to do all the transformations first. This one is left 4. again, I'm doing all the transformations. This one is right 7 and down 4. And, uh-oh, I can't see with this one. What does that one do? Right 5. And up 6. Is everybody all good? Okay with the shifting right and left?
Yeah.
And what that finds us right there is...
Wait, wouldn't the 4 be left 5?
Yeah. Oh wait.
Which one?
Because it's a
4.
negative.
Right, this one?
No,
And
number 4.
Over 4.
Left 5.
Left 5.
Because it's addition.
Left 5, thank you. So left 5, up 6. There we go. There we go. Okay? What else do they want us to find on these? They want us to find the axis of symmetry. Okay, so we'll do the axis of symmetry. Well, I know that my vertex went from 0, 0, and it shifted right. So that's now my axis of symmetry. Okay, this one, my axis of symmetry shifted left, so I went from 0, 0 to negative 4, 0. So that's my axis of symmetry. Again, that's a imaginary vertical line that allows us to do a mirror image over the top. My axis of symmetry on this one is x equals 7. My axis of symmetry on this one is x equals negative 5. Seem okay so far?
Yep.
You keep saying, what's this vertex garbage? Not there. We'll get there, I promise. All right, identify the vertex. Okay, so the vertex on this one's just going to be 3, 0. This one is going to be negative 4, 0. This one is going to be 7, negative 4. And this one, last one, is what? Oops, I went the wrong way.
Negative 5, 6.
Negative 5. Negative 5 in there, right? So left 5, so negative 5, 6. And then find the Y-intercept. Ooh. Y-intercept. So the Y-intercept, I'm plugging 0 in for x. So this is going to give me 9. Do you agree? If I plug 0 in for x, negative 3 squared is positive 9. This one is going to be 16, but I have to remember the negative out front. This one is going to be Y-intercept. Uh-oh, okay. So that's going to give me 49 minus 4. 49 minus 4 is 45. And this one, I'm going to plug 0 in for x. So I get 25. So it's negative 25. Negative 25 plus 6 is negative 19. And decompress for a second. We just kind of hit a whole bunch of stuff. Okay, so does everyone feel comfortable with the right, left, up, and down shifting of the vertex?
Yeah.
Is anyone stuck on that?
No.
Okay, so the vertex is handed to you. If you know that it's going to shift right or left, or you know if it's going to shift up or down, it's going to identify the vertex for you because the vertex normally was at 0, 0. Question.
What do you do if there's a negative sign in front of the...
That's just going to make the parabola open upside down. It doesn't affect the vertex. It just says the parabola is going to go down. Cool? May I move on?
Yeah, I guess so.
Yeah. How many more slides do I have?
Like 8.
It's like a phone book, dude. All right.
You're 6.
So here we go. Ready? Vertex on this. Does everyone feel comfortable how I just found the vertex?
Yeah.
So negative 3, negative 2. Agree? So let me stop there. Let me stop right there. Are we okay with that?
Yep.
Okay. So will that parabola that I'm working with right now, we'll do this whole one in purple. Will that parabola open up or down? Up. Does everyone agree it opens up?
Yes.
Anyone stuck on why it opens up? Okay. So I can pattern graph now. I don't have to worry about all the things. A lot of people are like, oh, make a t-table. No, don't do that. Okay, ready? Is there anything other than the number 1 outside of this?
No.
It opens up?
Yeah.
All right, from this point, I'm going to go right 1, up 1, left 1, up 1. Make that happen. So right 1, up 1, left 1, up 1. Is that okay? I'm stopping there for right now. Does everyone feel good with that? All right, so now from these new points I just did, I'm going to go right one up 3 and left one up 3. Because it pattern graphs with 1, 3, 5. Because the difference between squares is the odd numbers. Okay? Now this last one, if I wanted to go further and we have space, is going to go right one up how many? 5. So 1, 3, 5, and then 7 would be the next one after that. So from here, I'm going to go right one up 5. What did I just find where my finger's at? The Y-intercept. Definitely talking too much. Are we okay with that? Okay, again, the 1, 3, 5 is a beautiful thing. Turn around for crying out loud. No, quit acting like you're being victimized. You're off task.
I'm on task.
No, you're not. You're so off task. All right. The green one. Vertex. What's the x component of the vertex? 2. I heard it. 2. Positive 2. It's shifting right. So 2. What's my y component of my vertex? 8. So 2 comma 8 is my vertex. It's going down. All right? So 2 comma 8. And it's going down because of this. All right? So let me plot 2 comma 8. There's my vertex, agree? So it's not going to graph at 1, 3, 5. It's going to graph how? -1, -3, -5 because it's opening down. So from here, I'm going to go right one, down one, left one, down one. Okay? So right one. So from those points I just drew, it's going to go right one and down how many now? 3. And left one down 3. Hey, what did I just find on that? Y-intercept. Now I could go right one down 5 and left one down 5. So a few things I want to draw here. I want to draw this. I want to draw it straight because I can't draw straight to save my life. What do you think that pink line is? Axis of symmetry. So the axis of symmetry on this one is x equals -3, and on this one is x equals 2. Okay, again, the axis of symmetry is an imaginary line, but if I were to take my graph and I fold it over, notice this point maps here, and that maps there, and this maps here. The vertex doesn't map onto itself because it's the axis of symmetry. The axis of symmetry is not always needed on a graph. It's just sometimes a nice thing to go. So I have 2 different parabolas. One opens up, one opens down. Does everyone feel comfortable with how I've been handed the vertex so far? These are in vertex form because it identifies the vertex. Okay? May I move on?
Yep.
Sweet. Come back here because I'm trembling too much when I'm writing. Sorry. You guys get the doctor.
Oh, look, Olivia's reading her book. Good, she's not even on task.
I understand this.
You do not.
I do.
You don't get the bellyache once in a while.
Okay.
Vertex of this one is what? 4, 1. Do we agree? What's the axis of symmetry?
4.
X equals 4. Is that okay?
Yep.
So 4, 1. So I'm going to go 1, 2, 3, 4 and up 1. How is this one going to pattern graph?
Multiply everything by 2.
Multiply by 2. So I'm going to go right one up 2, left one up 2, and then 3 doubled is 6. So I'm going to go right one up 6, left one up 6. This one had a vertical stretch by a factor of 2. Agree? Hey, can I see my y-intercept at this point?
No.
It's off the graph. Agree?
Yes.
If I want to find my y-intercept, I'll plug 0 in for x. I get negative 4 squared. Negative 4 squared is 16. 16 times 2 is 32. 32 plus 1 is 33. So 0, 33. So that's going to be way the heck off my graph. Agree? Does it exist? Yes. All right. Can you guys see the difference between red and green? Any of my colorblind people that are just seeing stuff that's brown up there? Sorry if you are. What's my vertex of the green? Negative 3, 8. All right, so negative 3, 8. Is that okay? What's the axis of symmetry? X equals negative 3. So again, I could make that if I wanted to. This is opening down. Agree? Do we agree it's opening down?
Yes.
All right. And I'm going to go down 1 and a right 1 and down how much? Half. Why is it half? Because my A value is half. So half times 1 is half. Okay, so then at 3, if I take half of 3, what do I get? 1.5. So from here, I'm going to go right 1 and down 1.5. Well, here's my 0.5 and here's 1. Does that make sense how I just did that? So if I graph this, it's going to kind of look like this. Okay? So the green one's a little bit wider. It doesn't grow as fast. It actually has something called a vertical compression because it's a fraction between 0 and 1 out front. What connection is there between the vertex and the axis of symmetry? Well, the connection is here. If that's the vertex, my axis of symmetry is always x equals the x component. When you have a quadratic that is in standard form, this is how you find your x component of your vertex, which is also your axis of symmetry. Okay? The negative b over 2a works very well when we are in standard form. Okay? Yeah? No? Stretch? Good. Give me 2 minutes, or a minute. Give me a minute. All right. So the red one, number 6. The vertex, negative 6 over 2 times 1. So what, negative b over 2a. Negative 6 over 2 is? Negative 3. If I take negative 3 and I plug it in for x squared, I get 9. If I plug it in for the other x, I get positive 18. So 9 plus 18 is how much? 27. 27 minus plus 11?
38.
Wow. We got a nasty vertex on this one. Yikes. All right. So we had enough time to get almost through. So I feel that you should have a chance to get almost done with worksheet 5B. I think you can get almost done. Almost done. So does that mean you put your name on it only and you're like, I didn't get it anymore? Yeah, that's the bottom line. Okay, I covered everything for you.
Yeah.
Have a great day, everyone. Take care of one another.
Thank you.